Our Goldberg machine is titled Homework, and our slogan is, "We hate the homework but love the environment." Order of content, we're going through introduction, design criteria analysis, design description, figures, summary, and pitch. Our company's logo is, "We hate the homework but love the environment. We find it very important to recycle and think that people living in dorms and community-style living don't do it as often or at all." Our task is to identify and present our customers with a machine that helps aids with everyday tasks and will directly benefit the students of living in dorms and community-style living by helping them recycle daily and more often. Our clients are Dr. Winklin and people who live in a community-style housing because, again, that's who our project is directed to, and we think that needs more help recycling and doing it daily. Our location influenced our project because our machine can be easily put in any living area. It is easily stored in a 3x2 box and can be put out on a table, small and ready for use.
So throughout a project, our machine has been assigned 5 different design criteria, and these design criteria make our machine the most effective and efficient at completing its task as possible. And the design criteria here have governed all the decisions we have made in presenting and constructing our project, and this makes the machine more accessible to the customer and more beneficial. So firstly, we have the runtime, and our numerical constraint here is that the machine is supposed to run in a greater time than a span of 10 seconds. So our construction, it needs to be constructible. So for the constructability, it needs to be easily built by an audience member or anyone else who purchases this product in less than 10 minutes. It should be affordable, and for this we have a budget of less than $25, and our group, as you will see in some of our tables coming up, we have effectively been under this budget by purchasing items that are less than $25. It needs to have some sort of engineering influence, so we have 3 different departments here at the College of Engineering at K-State, which we are taking influence from, and that is mechanical engineering, civil engineering, and architectural. And fit and safety, it needs to be able to fit into a 3x2 foot box, and all the parts need to be able to fit into the box and not like overflow or be deconstructed. So here is some of our criteria analysis, and this goes under the runtime and construction time. So we had 4 different people, 2 of which were not included in our design group, and we had tasked them to build the machine and to run the machine as well to see if it would work. And also we had the time to build and the run time. So as you can see, we are consistently below 10 minutes here, and we are consistently above 10 seconds, which both meet our criteria. Here is our very lengthy list of materials, and here, as you can see, each material is assigned a cost value, and all these costs added together are 25, so that means our team was at budget. And we do have a list of some materials which are not included in the cost, and this is because we found that we thought it'd be trivial to not include in the cost, and some of these materials probably students already have, so we felt there was no need to include it into the cost. So like, for example, a cardboard box or like scissors, any student should have that in college.
Alright, in our design overview, this is basis of pictures of each step. So the first step will start off with somebody dropping a marble into the funnel. That marble will go down its track and hit the red car at the end, leading into the bucket that will start our pulley system. That pulley system on the other side will go up, hit another cardboard tube with a yellow car in it that will go down and start our first domino line. That first domino line curves around to hit a movie case that will start our second marble track that will go down and down and down and down. That will lead to our increasing size domino set. And that will be in that picture, figure 6. and then that increasing size of domino line will hit this right here where the car will be standing with the homework attached to it. So whenever this last domino hits that base, it will shoot down that track and into this scissors contraption, and where it will remain stuck in the middle of the scissors, where second human input is needed to start the Hot Wheels launcher that will go through the loop-de-loop and hit this rock off the cardboard box, allowing the force to shut the scissors and cut the homework off of the car, ending up recycling the homework.
In summary, we hate homework, but we love the environment. Our homework machine solves the problem that we outlined, and that problem was to design a machine that could be used by an everyday person or Dr. Wanklin to complete a simple task. And in our design, we incorporated the 3 different disciplines: architecture, civil, and mechanical engineering. And our design met all the criteria that we set beforehand. And finally, our pitch: poor grades are bad, not recycling is worse. Take a bad situation and turn it around with this whimsical method of destroying your failed assignments. We're asking for $1,000 for a 20% stake in our homework machine.
Here's some recommendations that we would change to our project.
We would make sure we spent more time on having stronger bases for each of the pieces, making sure that everything is level and sturdy enough to withhold whatever task is going to be run through it.
We would also change to have some bigger pieces instead of lots of small ones like dominoes that were very hard to set up and get done in a timely manner. So having bigger pieces that wouldn't take as much time would have definitely saved us.
And lastly, our time management. Setting up meetings where we could all go to it was definitely something we started out to do, but once we realized not all people can make every week meetings, we lately realized that having meetings of just 2 or 3 of us does the same amount of effort as if it was all 4 of us, and so we canceled a lot. So if we started off having those 2 or 3 people at a meeting, whoever can make it, we would evolve our design a lot faster and have much more time prototyping and designing this whole thing.